Hi, welcome to organic third chapter, that is aldehydes, ketones and carboxylic acids. We are going to do more PYQs from organic chemistry connected to this chapter. So this is short one from organic chapter 3. Hi, I'm Prasanna. Welcome to my platform, ChemSmart. Let's see what are the questions. Question number 1. This is from 2023 board paper. It is give reason. Carboxylic carbon is less electrophilic. Less electrophilic means less positive, okay, than carbonyl carbon of aldehydes and ketones. We are going to see what the reason is. Let's see what is happening in carboxylic acid. You know, a carboxylic acid can dissociate to form carboxylate ion and H+. This carboxylic carbon is more stable, means there is a possible resonance happening in it. So we are going to see what is the resonance possible in carboxylate ion. And that resonance is the reason why it is more stable. So you have to learn this resonance drawing also. You know, this is carboxylic acid, right? Okay. This is structure number 1 when we draw resonance. So this is RCOOH. Now, what is resonance structure number 2? We have to see what type of shifting is possible here. Look. There is a shifting to more electronegative oxygen atom, making it negative, and this carbon will become positive. So to cancel this positive charge, one of the two lone pairs can get shifted here. So what will be the next resonance structure after the shifting? It is C. Now, double bond becomes single bond here. Already two lone pairs are there and one more pair is getting shifted here, making it negative, right? It's going there, so making it negative. And this plus and this lone pair will make a bond here. So O and then H. Out of the two lone pairs, only one is there now. The other place, it is a plus sign. So this is structure number 2. So you can see that this carbon, that is the carbon atom present in carboxylic acid or carboxylate ion, is less positive. What is the reason? Because the lone pair is getting shifted there to cancel that plus charge partially, right? So it becomes less electrophilic. Less positive means less electrophilic. But if you simply take a carbonyl carbon, there is no such reduction of electrophilicity happening due to resonance. Okay. So this is the reason you have to practice this drawing very well. Now, going back to the question. So I think first question is clear to you. It is due to resonance and draw it. Propanal is more reactive than propanone towards addition of hydrogen cyanide. You know, hydrogen cyanide addition to an aldehyde or a ketone is a nucleophilic addition. And nucleophilic addition in ketones is more difficult compared to those in aldehydes. What is the reason? 2 reasons, steric reason and electronic reason. Let us compare propanal and propanone. We are going to see what are the structures of propanal and propanone and compare them. Okay, so what is propanone? Propanone is CS3CO CS3, propanone. And what is propanal? CS3 CS2 CH double bond O. This is propanal. CHO I just expanded like that. Now, C double bond, I'm just drawing propanone like this to show the hindrance and reduction in electrophilicity. And this is propanal. So C double bond O, CS3, CH. Now, let us compare. 2 reasons, electronic reason and steric reason. Sterically, what is happening here? Look. You know, this oxygen is negative and this carbon is positive. It is because of shifting of electron in this pattern. So this carbon of C double bond O is the electrophilic center because it is turning positive. Now, if this carbon is highly positive, it will be highly reactive towards nucleophilic addition because nucleophile is negatively charged. it will attack the positive electrophilic carbon. It will get connected to the positive electrophilic carbon. So the more the positive charge on the carbon, more will be its reactivity towards the incoming nucleophile. Clear? If there is any reduction in the positive charge on carbon, it will be less reactive towards the incoming Nu- nucleophile. That is what we are going to check. And nucleophile is a negative ion, so it will be a bit bulky. And if there are bulky groups surrounding the carbon, the electrophilic carbon, the entry of nucleophile will be hindered. That is called steric hindrance. So when a nucleophile is coming here to attack this, just imagine there are two bulky methyl groups here in propanone, which will hinder the entry of the nucleophile. That is Cn minus coming from HCN. Hydrogen cyanide is a question here. So there is steric hindrance, more hindrance surrounding the electrophilic carbon compared to less here, because there is only one bulky methyl group here. The other one is a small hydrogen atom. It doesn't offer much hindrance. Clear? So more steric hindrance. So the entry of Nu minus will be comparatively more difficult in propanone compared to propanal, making it less reactive. That is a steric reason. What about the electronic reason? When you come to electronic reason, think about the inductive effect of the alkyl group in the ketone. So if you come to the inductive effect, see, this methyl group is having positive inductive effect, plus I. This methyl group is also plus I. That means both are electron releasing groups. So they will release electrons onto the carbon. When more inflow of electron is coming to carbon, the electron is negatively charged. So it will cancel the positive charge accordingly, right? So the more the inflow of negative charge electrons, lesser will be the positive charge. So here, the positive charge on carbon will be dramatically reduced due to the plus I effect of the two alkyl groups connected to the carbon. But here there is only one. So only one alkyl group is releasing electrons. Comparatively, there is less reduction of the positive charge in the aldehyde compared to ketone. So we can say in short, this carbon is less positive compared to this carbon, which is more positive. More the positive nature, more will be the reactivity in nucleophilic addition reaction. So this is less reactive, this is more reactive. Suppose you get a question in general format, then you will just write R here instead of methyl. Here also you will write R, and you can explain in same way using the two key concepts, that is steric and electronic reasons. Clear? Practice so common. So we have completed this session. I hope all these questions are okay for you. You got the ideas properly and the applications properly. See you inside for the next session. And make sure to like, share, and subscribe to my channel, as I always tell you. And also make sure to watch all the other videos which I have uploaded in my channel. Okay? It will help you a lot. See you for the next session.